final panel. Um, we're going to start because we, like Sachit, we are starting 6-7 minutes late, and so we will try to catch up, and if not, we will end 6 minutes late. So this is the session, that's session 5 in the agenda. It's called Methods and Tools to Enhance STEM Education. I'll just introduce my panelists, but I'll introduce them in the order that they will speak. First is Dr. Dmitry Popov, who is, Dmitry, wave to the crowds. That's Dmitry. Dmitry is a Technology Development Fellow at the Wyss Institute for Biologically Inspired Design at Harvard University, and works on robotics, and he will speak about that. To my immediate right is a local boy, Ankur Goel, who is a graduate of IIT Delhi and now doing a fellowship also at the Wyss Institute with Dmitry and his colleagues. And to your extreme left and my far right is Mr. Ramanan, who is the mission director for the Atal Innovation Mission at Niti Aayog. So thank you to all the panelists for being here. And the agenda, let me just say a word about the agenda. What we try to do here is bring together, I said at the outset of this conference that the idea here is to build bridges between different parts of society. So here, Ramanan is a private sector gentleman who has been borrowed by the government, so to speak. So we have in his persona a bridge already, in some sense. But he's representing here Niti Aayog and the government in its policies to trigger creativity and entrepreneurship across India. And in the persons of Dmitry and Ankur, we have some scientists who are working on some pretty cutting-edge ideas in soft robotics. But the purpose of this panel is not so much the soft robotics per se. It's more using it as a device to say, how could we take that into the high school classrooms to excite the kinds of things that we've been speaking about in multiple panels this morning. You know, curiosity, as I think it was Yamuna who was saying earlier, why is the sky blue, and things like that, natural curiosity. But how can we make that happen with a concrete intervention? And then in my imagination, what I'm hoping is that Ramanan can tell us how, if this sort of experiment, again as an exemplar, were to succeed, then how can the government help us scale it across the length and breadth of schools across India. So that's the agenda. So Dmitry and Ankur will go first in that order, and then Ramanan will tell us how we will move rapidly to world domination thereafter. So, okay, Dmitry, go for it.
Thank you. Can you hear me? Good. Well, first of all, thank you for inviting us here. It's really great to join you here. And
can you hear? Can you put the other mics on too, if in case this one is not working for some reason? Just bend it towards you.
I guess I'll move here. Is it better this way? Okay, I can hear myself. Thank you. Again, thank you for invitation. It's really great to join you here. Actually, we had a chance to see the work of that Mr. Ramanan and his team does, and we had a chance to join one of the labs that they have facilitated in the schools here. And it was quite impressive, and it was impressive in the way that we can see how the resources are being used, and from the different sides. So we could see how the projects that students have developed are quite impressive, because it's on the level of university. You can see the project they have developed, that's similar things that people do in university level. The way the teachers are getting excited about it, and how they implement the materials, and of course the resources you provide. And technology and innovation, of course, it's important to bring to the younger age, but it has its own challenge to do that. And the challenge is always, every school is different, one from another one. Every teacher is different, and age groups are different, what the kids actually can learn at what age. And it's a question really, how do you provide and develop the materials that can be used in these different environments? So that's what we do at Harvard. We develop educational materials on how to teach robotics and how to provide the materials that can be used in the different environments, and the teachers and students can take from it what they can take, and at the pace they can take. And I would love to actually maybe use a presentation to introduce the work. Thank you. So the project has a name of Soft Robotics Toolkit, and we have chose this theme of soft robotics because, as Tarun has mentioned, it's one of the new areas in robotics
traditional robotics, it's very rigid, and we have shifted to this new field of soft robotics that can be more applicable in the application when it interfaces with a human. If you want to wear it, it's safer. So the original project began in 2014, and the question was, how do you introduce the education in a more fun, clear way? And so what we've done, we developed several tutorials where teachers, it's an open resource so anyone can download, and you can follow the link on top on the right, the softroboticstoolkit.com, and any teacher can download the materials. It has a step-by-step guideline on how to conduct the workshop to build one of the robots we have proposed. And there is a list of the materials you need to purchase, and where to purchase, and how much they cost. As well with that, we provide some articles on the cutting-edge research in soft robotics from other groups. There are more than 19 labs participate in this platform. They share the research they do, so we can share it with the world. And people or students and teachers can actually try to do that and learn something from that. We also share open source materials that people can download different parts to 3D print and experiment, let's say, with molding or making different, for example, soft fingers or soft animals like robots. We also conducted different competitions. So once a year, annually, it's an annual thing we do. We have a lot of participants. We submit from all over the world. It's mainly high school students. Some are from the universities. We have a panel of judges, professors from different universities help us, they evaluate them, then we choose the winner. So if we look at the statistics, it's about 195 countries that have been visiting our website to see the materials. We have about 2 million views. But if you think about it in perspective, maybe a cute puppy or a funny cat can get more views on YouTube in less than a day than this, and 2 million. So we were thinking, what is really the effective way to outreach, to bring this to the real world? And eventually, we decided to move to a kit, a physical kit, so there is not really a barrier. What we noticed that teachers, even if though you provide them all the resources, they sometimes feel afraid of how to use it because they've never done it before, and they don't want to just open it, they don't know what if they fail. So what we try to develop is a kit that essentially children can take from the beginning and bring to the end and have a robot essentially without assistance of a teacher, and teacher is really there to facilitate the project and help them. And if you look at the process, how we do it, what the kit does, it first starts with ideation. Why do you need to make this robot? And first, the idea is that we want to grasp an object, so kids would choose an object. Then they build a mold, then they use a resin, they mix a resin together, they put it in the mold cures, and they get the finger, a soft finger out. Then they assemble a gripper, and then there is part of freedom comes when they can modify the way the gripper grasps an object, the way they move by adding these attachments, the plastic attachments. And then finally, it's a part of fun where people, like students, would experiment what to do with it, grasp it with 2 fingers, with 3 fingers, different motions, etc. And it's always a question because some teachers, they want, again, they're afraid of how to use it and they want specific instructions on how to follow them. And some teachers want freedom because they know it well, they've been in robotics for a while, and they really want to just have some materials and free to do whatever you want. And it's a question, it's been one of the biggest challenges, how to develop the material that is free enough and really teach you real robotics without constraints, and yet you make sure that every kid can complete it, every kid will come to the same result, so they actually learn from it. So that's how we try to navigate, and that's how we make these kits. So this is not only one kit, of course, and it's a series of kits, but every kit has a build on top of it. So as an example, you can see on the left is a manual gripper. Any kid, let's say from the age group of 5 and above, not the age group, sorry, the grade, from the 5th grade and above, can complete it more or less successfully. Then there is an electronics kit that builds on top of it. With this kit, what you would learn is really actuation, simple electronics, basics of the motor and batteries, etc. And then finally, we can move to this programming stage where you can introduce the microcontroller and sensors, and it becomes almost an open platform and doesn't really have an end to that. So these can be used in different scenarios. You can imagine, for example, teachers taking it and use for 11th grade and do a full course in 2 weeks where they do the full thing. Or you can see it also in the scenario where the kid starts, let's say, at the 5th grade, They come back at it at 7th grade and then at 9th grade, and etc. And this is just one idea. Another idea that we're developing is this pneumatic-driven kind of a skeleton. And the idea is that what do we really teach with these kids? It's methods of manufacturing. What do you make with it? Is understanding of electronics and again programming. We don't go into the programming too much because there's so much materials out there. We don't want to teach that. We really want to teach hands-on skills and basic understanding. So most of this stuff was being developed in Harvard, and recently, about a year ago, we got the sponsorship from Tata that helped us to develop it further and figure out how to bring it to the Indian market, to the Indian schools. So this was our first attempt at this trip to try it in the workshops, and I will pass on to Ankur from here, but before doing that, we'll show you a video. It's a 30 seconds video of the experience that team had, and was quite a blast, so let's see it. Great. So this is what the guys have done. It's been a workshop for 4 weeks, and Ankur will talk about this. Ankur joined us about almost a year ago at this point, and he's a great example of the patient and smart students from Indian schools, so I think he will explain it well.
Thank you, Dmitry. And thank you for putting that video together. He was probably up whole night last night trying to put that together. So, a little bit of my background. So, I did mechanical engineering from IIT Delhi, and I finished my undergrad very recently. So, I'm still like in the school in Indian system only, and I'm currently working on the Soft Robotics Toolkit. So, and my role there is basically I make the toolkits. I'm the developer, and Dmitry is obviously the guiding light. And my interests are also in science, technology, and how state can interact with science and technology through policies. And this is because of some good professors from IIT Delhi. So, and that's why I find myself here on this panel. So, I'll give you a little bit of brief as to what were our experiences and findings from the workshops that we conducted. So we wanted to test a couple of things that were whether or not students from Indian classrooms are able to make these toolkits, what is the age group that is most comfortable with them, and what is the lessons that they can take from these, and how much are they actually going to learn from not the books, but a hands-on experience like the one that is Soft Robotics Toolkit. So to give you a brief summary, I would say that all the students, so we ran workshops with students from government schools as well as very high-end private schools. And we ran workshops with students from age group of class 4th to class 12th in order to test certain hypotheses. So in summary, all the students from each classroom or each school, they enjoyed making the toolkit. So, and all of them were able to completely make the gripper. So we tested the electronic gripper that you see on my right, and all of them were able to make it. So the students from below grade 5 needed a little bit of assistance from the educators in making the toolkit, but the others did not. However, all the students needed educators' assistance in order to answering questions, in order to solving certain creative problems while they were developing the toolkit, and also just in things like basic teamwork. So that being said, so the reason that we mention this, that the reason that this comes up is because we are trying to make solutions that would provide educators with tools of teaching something that they are themselves not very familiar with. However, students can still learn, and the role of educator does not become unimportant, even when they're learning something that educators are not previously aware of. Then we also realized that all of the students learned. They had certain lessons taken out after they were finished making the toolkits, and the parameter for that was like how much of creative questions they were able to ask, how much they were able to inquire about the materials of the toolkit, the processes of the toolkit, what can be the alternative uses of it, what can be the alternatives of the processes that are being used in there. And another interesting finding that we had was the one that we are probably most concerned with in this panel, in this whole event, is that how much are they already familiar with the kind of curriculum we want them to know. So the students from the high-end private schools, they were mostly from privileged backgrounds. They were mostly like teachers' wards, and they had already had the experiences of playing with robotics kits like Legos and Avishkar and everything. So when they were interacting with the toolkits, they were extremely comfortable. Not saying that they were better or worse than the students from government schools, they were definitely more comfortable. And the students from government school, however, felt very nervous when it came to actually making the toolkit, and especially when it came to asking questions about it, and especially when it came to tweaking certain things into it. So as Dmitry explained, that at the end of the activity, we just leave things open for students to do experimentation. The activity calls for students to actually be motivated and try and test certain ideas, the ideas that we are not even telling them, the ideas that are their original ones. And while we are actively telling them to, the students from government school felt very nervous while trying any new thing with the toolkit. So that is majorly the concern. Now I would just to give a little brief as to how I see this whole conversation going regarding STEM education and enhancing tools for that. I see that there is gap between methods and as well as the contents. So we focus a lot on rote learning and not much on the inquiry, not much on asking questions, and especially almost not at all at hands-on experiences. There are definitely logistical concerns. The sheer number of students in India is large, and that poses such problems. But then again, this is a real problem, that the methods are not enough or not efficient. And then the second is the content. What are we trying to teach with whatever methods do we have? And in that, we are keeping the contents to a very obsolete times. The contents that we are trying to teach is getting obsolete, not only in schools, but also in engineering colleges, in the most leading engineering colleges in India. So both of these need to be addressed, and Soft Robotics Toolkit is basically our attempt at trying to address both of these problems, as in this is almost cutting edge materials. Soft robotics is a buzzword as like artificial intelligence or genomics. So this is a cutting edge research that we try to pack into a classroom activity, and we try to teach it with a different method, with a hands-on experience rather than rote learning. So having said that, that is basically the brief summary of my thoughts. Now my questions would be, I would like to end with questions like, how can we ensure that the educators that we currently have, because those are large numbers, they be aware and they be comfortable handling such tools, because that was the first motivation how the Soft Robotics Toolkit changed its direction from just an online website to handheld products. And how can we enhance the use of these toolkits in Indian classrooms? Thank you.
So before I hand it to Ramanan, I just had a couple of questions to clarify. Dmitry, you said that people from 195 countries access the website, not the toolkit, the website, right? Yeah. But do you have any observations on at least maybe school kids in the US and India, whether you saw any differences, or is it just that kids are kids and they're all equally curious?
Yeah, I think the short answer is you're right. Kids are kids, and it's really about how much you invest into them, like how how much they were exposed to it previously. So I think if you design the activity really well and you make sure that anyone can do it all the way to the end, it's all about the question, how shy are they or how confident are they, so how quick they will do it, but that's about it.
And is it the case to both of you that what's being illustrated is, I take it, some general principles, right? Principles of robotics or principles of basic physics or mechanics, or circuitry for that matter? What is the learning objective with this kit?
Okay, so the learning, so how we design these toolkits are we take certain initial concepts of soft robotics primarily in mind, and we then build on those, trying to make them. So like the gripper kit, it teaches mold design, shape deposition, manufacturing, and cable-driven actuations. And the electronics part of it, it teaches basic electronics like just handling motors, LEDs, and batteries and switches. So, yeah.
So general skills that can be, or principles that can be applied to other contexts also.
Yes.
Okay, great. Thank you both. Let's transition to my colleague Ramanan. Ramanan, you want to introduce your AIM mission and things like that?
Yeah, thanks Tarun, and thanks for the opportunity to participate in this, I guess, a very, very important event, not only for all the people in this room, but outside. To my left are two young, very dynamic innovators, and I just want to assure you that I'm young in spirit, though not in age, as young in spirit as them. So the Atal Innovation Mission is addressing a number of things that we talked about in the afternoon today, as well as things that were raised just now by the previous speakers. Essentially, the mission is all about how do you create and promote an ecosystem of innovation and entrepreneurship across the length and breadth of the country. Why do we need that? We have 1.4 million schools in our country. We have 10,500 plus engineering institutions. We have more than that number of colleges. We have an equal number of management institutions. We have 150 million students who are going to be entering into the workplace over the next 5 to 10 years. We have 1.3 billion people riding on the hope that these 150 million people are going to carry them through the next century. So with this awesome responsibility lying on the shoulders of all the young, from school to college to universities, it is very, very important for us as a country to create an ecosystem of innovation, to create an ecosystem of entrepreneurship, where we are going to create thousands of job creators, not just job seekers. And the previous speakers did mention that our learning system, while it has served us well so far, has been primarily a rote learning based system. We try to get good marks, get into a good university, try to get good marks again, get into a college, get good marks again, get into a job, IBM, TCS, Wipro, Google, and so on. So we are not trying to become job creators, we are trying to become job seekers. And that is a paradigm shift that needs to be done in the country. So how do you do that? You have to do it in a very holistic manner. So at a school level, what the Atal Innovation Mission is doing is we are launching thousands of tinkering labs, what are known as Atal Tinkering Labs. These are having latest technologies like 3D printers, robotics, IoT devices, miniaturized electronics, augmented virtual reality, do-it-yourself kits, like the kits that you saw just now. And these do-it-yourself kits are introduced for students between grade 6 to grade 12, so that these students get a chance to actually play with these technologies, tinker with them, as they say, in an atmosphere of fun, in an atmosphere of learning, with no pressure on them to get marks and get qualified and prove themselves to anybody. They just have to prove themselves that they can create solutions and they can be innovators. And what we do is we launch thousands of challenges to them. At the school level, we launch tinkering challenges, which will stimulate creativity, which will stimulate curiosity first. And then it will convert that curiosity into exploration. That exploration is converted into tinkering with technologies that are made available to them. And that tinkering leads on to creativity, and that leads on to problem solving and innovation. So what we do is we tell the children, look at the community around you. Look at from when you're coming from your school to your home, or when you're going and visiting a mall or a park or a hospital, just look at what are the problems that are in and around your community. And are you able to identify problems that you think you can solve by converging together, deliberating on it, using these technologies, and creating solutions and creating prototypes? That's what we do. And so these Atal Tinkering Labs we have launched. We are already selected 9,000 plus schools across the country, and 3,000 of them are already operational across 650 districts that our country has. The impact of this has been fantastic. It's all happened over the last 2 years. We run tinkering marathons on an annual basis, and these tinkering marathons, we identify sectors like health, care, or waste management, or clean drinking water and sanitation, or transportation, smart mobility, and so on. We throw challenges at the students. We say, can you go and find a problem in these areas and come and create a solution? And then submit those innovations over the net to us, and there will be a validation of that, and the finest innovations will get recognition. In the last tinkering marathon that we ran, more than 8,000 innovations got created by over 45,000 students across the country. And 1,500 of them were selected by a marathon day in every school, where not only the teachers and the students displayed their innovations, but also parents come. Because the biggest hindrance in India is that the parents are the first bottleneck. They don't allow the children to express their creativity. They don't even understand that their children are so creative. And what has happened in this adult tinkering labs is, as a result of all of this, you find that not necessarily the best academic performer is the greatest innovator. And the best innovator is not necessarily the greatest academic performer. And so now you're able to see that there is something in every student, and that latent innovative talent comes to the fore through these tinkering labs. The second intervention that we are doing across the country is we are setting up what are known as world-class incubators, Atal incubators. Why incubators? Because we need to create an environment where startups can be fostered, can be succeed, and startups have various valleys of death, as they call, because of lack of mentoring support, venture capital support, hiring support, business plan and strategy support. So because they don't have the support, they die sometimes in these valleys of death. But through an incubator where we are giving 10 crores of grant to every successful applicant, we are able to create an environment and an ecosystem where these startups can thrive, and they can become unicorns, or they can become great companies. So we have launched about 101 incubators, and every incubator would foster 50 startups every 4 years. So which means around 5,000 startups would be fostered in the next 4 years. The third intervention we are doing is to stimulate product innovations which are relevant to the nation, which is having economic impact or social impact. We are launching what are known as Atal New India Challenges. These challenges are being launched along with ministries, because the ministries can become the first buyer, potential buyer of the solution, and these challenges would provoke innovations which can then be applied. And we give a grant of up to 1 crore for every successful applicant who is able to prove that either he or she is having a proof of concept, a product, or a prototype, or a patented innovation which can be applied. And finally, to bring it all together, we are creating a Mentors of India, Mentors of Change network. And this Mentors of Change network is to make sure that individuals like you, professionals like you, across the country can contribute to these Atal Tinkering Labs, to the startups, to the incubators, mentor them, because you're not going to have all the teachers in the system having the necessary knowledge or the expertise or the market knowledge that is required to promote innovation and to create innovative solutions. So we have put together a network of mentors. More than 10,000 people, we're very surprised. More than 10,000 people registered on this network. We have mapped 3,500 of them to these tinkering labs, and now we'll be mapping them to the incubators and startups. Bottom line in all of this is creating an ecosystem that is self-sustaining, that can scale up in a remarkable manner, and which can then further grow. And what we have been very pleased to see today, I mean, I have a number of Atal Tinkering Lab students, I think, who are over here. A big hand to all of those who are participating in the innovation drive. What has struck me most, coming from the private sector after 30 years and joining the government, is the enormous talent that is there in the country. Give them the reach, give them the access to technology, and they are able to fly with it. We are having solutions, IoT-based irrigation management systems, solar panel-based irrigation management system done by a school in Thoothukudi, which is in the remote coastal Tamil Nadu. Many people don't even know where Thoothukudi is. And from such a school come out a set of students who have created a solution that is being used by the farmers there. In Sikkim, we have a set of girl students who have created a robotic waste management system. We are having solutions. An Ayurvedic spray has been created, one of the top 30 innovations, where microbes can be killed using that spray, Ayurvedic spray. And there's a bunch of 10th and 11th standard kids. So the capability is enormous. How do we tap them? By giving them this opportunity and being able to do that. So I have a small video which I'd like you to see how this is spreading across the country, and after that we'll be happy to take questions. Before I end it, I have to say, this was the brainchild of Mr. Tarun Khanna and a set of eminent thinkers across, and came a Tarun Khanna report. So I would urge every one of you to read that particular report, the Tarun Khanna report. And I want to thank
So Ramanan, before we open up, I had a question. You mentioned, and I want us to focus on the tinkering labs because it connects to the robot
Right.
and to the idea of STEM education. But before we go there, the challenges that you mentioned, maybe you can give a couple of examples of what the challenges were so that people can relate to the idea of science.
Yeah. So almost all the challenges, I mean, we identified, for example, 8 sectors this time in the Tinkering Marathon. We said smart mobility, clean drinking water, electricity for all. We had urban housing development, smart homes, and we had design, urban planning and design for smart cities, and so on. So the challenges were find some solution in any one of these, and identify a problem and find a solution. And out of that came solutions like this, like what I said, irrigation-based, climate smart agriculture or precision agriculture. And so the challenges, when they are thrown, the students go and engage with the farmers, for example, and identify what are the problems that the farmer is facing, or the pollution problem that is there in Delhi. Some of the students went and found a particular solution for and it's a prototype of innovation. It may not be the ultimate solution, but the fact is that 10th standard and 11th standard kid is going and creating an innovation based upon whatever they are seeing and observing and coming back and deliberating on it. That is what we are actually looking at. But the type of innovations which have come out, the top 30 innovations which came out last year, have been adopted by corporate multinationals, and some of them, 6 of them, are being actually commercialized into a product. So the innovation standard is very high, and as Dmitry said, like, though it is at the school level, some of the innovations are equivalent to what university students would do.
So thank you for that. I wonder if any of the panelists want to comment on if somebody were to come up, like at the Wyss lab, you guys have come up with this Soft Robotics Toolkit. Does it make sense to think of Ramanand's Tinkering Labs as a platform where we can just introduce this into it, and tomorrow, Shannon sitting here could come up with some way to communicate ideas about ecology, or somebody else could do it about life sciences. To what extent is it feasible to think of it as a plug-and-play system where somebody has an idea and we plug it in and roll it out? Because ultimately we need a continuous influx of ways to excite the kids, right?
Yeah, I think, again, as a scientist, as an innovator, it's always hard to bring the the technology all the way to the end. You have to know a lot of expertise, distribution and management, all of that. And I think if there is a platform like Mr. Rahman and his team does, I think it's very helpful for us to employ it. And again, I think they will be always looking for some new modules, new curriculum to introduce. There's no like one idea that you introduced, and it will really help the school to foster throughout the years and be engaged and stay with it and be satisfied with it, because there is no robotics or any other education. It's a very large field, right? So you cannot really teach it with one kit. You can give some exposure to a kid with one kit or another, but it takes years to eventually skill it up, right? So education system is not like it's terrible. It all has got here, right? We do something, but it requires just maybe small advancement and small introduction, relation of theory that's been taught over the years with the real applications. And I think what we do and the platform, it allows to introduce this relation between the theory they learn in schools and what can be done in real life.
So if I may add to that, Tarun, we are actually, the ATL platform or the Tinkering Lab platform is an ideal platform to keep upgrading, and we want to keep upgrading that. And right now, for example, we are seeing, because of the tremendous amount of interest in AI and blockchain, whether we can have an AI do-it-yourself kit, a robotic do-it-yourself kit, blockchain do-it-yourself kit, so that the students get introduced to those concepts, they can play around with that, and then they can build upon it. And there is an element, and these solutions are for any branch, whether it is, as I think one of the speakers said earlier, Uma, I guess, she said that today innovation is all about blending a number of disciplines, physics, chemistry, maths, etc., and bringing them to bear in a particular innovation. And so you need knowledge of all of that, and so these kits, which the one which I saw, would be an ideal one to integrate, as long as we are able to find a way of and a mechanism of reducing the cost and being able to scale it up to the requirements that we have.
Great. Why don't we open it up, and then we'll see if I can orchestrate a conversation. So as with the previous panels, please just keep your question fairly sharp and ask a question if you can. The gentleman at the back who had his hand up.
Hi. So my question is that India, through science fairs or even through ATLs, India always had a very localized innovation system, which in other terms sometimes called frugal innovation system. Most of these innovations are very good at a local level to solve a local problem. So what can we do to sort of scale that system up at a national level or even at global level? And secondly, when you talk about ministries becoming the first buyers, so I run a startup, and in the ecosystem, many friends and us, we have always faced this challenge of a specific solution because of the sort of nitty-gritties and the system that is put into place. Most of the time, startups probably can't get the sort of the bid or even they qualify to submit the innovation, which can be scaled at a ministry could give them the scale, but they can't. So what can we do about it? So thank you.
Yeah. So the first question that you asked is, many of the problems are local problems, and how do you ensure that it can have a global, that it can be extended globally, or it could go up to more than just the local problem? And I guess, first of all, there is a need for local solutions in India, because even every state has a different sort of problem. If you look at Delhi, air pollution is a big problem. If you look at Mumbai, it is urban migration is a big problem. So there are different problems every state and every district has. So it is good to get localized solutions. But at the same time, what we are doing is we are introducing them to a potential of scaling it up and making it relevant to the global context. And for that, there has to be a handholding, and that is how, when we recognize a particular innovation has that potential, then we put together mentors, we put together partners, some of the corporates adopt them, and then see how we can scale it up to the next level if it has the potential to be scaled to the next level. In terms of the second question that you asked, the buyers. So the challenges are one route of exposing the quality of the innovation to the ministries and to various other departments. Otherwise, whenever they come up with a bid, they don't even know what is out there. But through a challenge route, you are able to get the necessary visibility and exposure that your innovation has. And because it has gone through a challenge route and it has evolved through that, there is a potential for the ministry to at least experiment as a pilot for the startups, and pilots can be pretty significantly large. You know, it need not be in India, a pilot within a city is a project in many other countries. So you can have pilots, and you can then prove the efficacy of your innovation, and then it will have a path of its own. And you will the other idea that what we are doing is we are plugging them with investors, other investors, and the incubators and so on. So it is not just winning a challenge. It is plugging into a network of potential people who are able to see the value of what you are doing and are further investing in it and also creating new markets.
I realized that I neglected to ask a question, Ramalan, about the ATLs, which is you're seeing all this interest in playing and educating through play, which is really quite wonderful. What have you collected any information, hopefully more than anecdotal, about the effects on the mainstream education system in the same schools where ATLs are introduced? Can you comment on that at all?
Yeah, so we are collecting that, Tarun. We are so we are very conscious of two things. One is we have identified a dashboard, real-time dashboard, where we capture 8 or 10 parameters. Some are leading parameters of the utilization of the ATLs, and other are lag parameters, which are the outcome parameters of the ATLs. Like how many innovation projects got completed, how many innovation projects got started, how many students got trained, how many of them are participating in external challenges, and so on. So we are so that is one aspect. The second aspect that we are also looking at is there an indirect effect on the academic performance of many of these? Is there a correlation between the fact that you're exposing somebody to tinkering and the knowledge of the subject also being gained? And why anecdotal evidence is there that these students are now understanding physics, chemistry, math a little better because they're actually applying and creating solutions. And what they're learning in theory seems to, they suddenly become, it opens up their interest in understanding that subject better. For example, if you're doing remote sensing in a sensor technology-based drinking water solution, they want to understand the chemistry of water, the pollutants which are there, the arsenic which is there, etc., etc. Their research capability increases, their curiosity increases, and at the same time, when they're applying the technology, their appreciation of that scientific knowledge also increases. So what we are confident over the next 2 years, and we'll be publishing results on that, and we're also conducting some surveys along with Harvard and other organizations, is what is the correlation that we are able to see between the tinkering labs and the effect on academic performance, and vice versa. And also, what is the impact in terms of when they go into the university, and the impact on the startup industry, because all these students are going to go into universities, they're going to be more confident of being innovators and more confident of starting startups, and I'm sure that also has to be measured over a longer term.
That's the aspiration.
Yes.
It takes some time before this gets to that point. That's somewhat, yeah, sir, please.
So this is Dr. Abhijit. I'm from St. John's Medical College, Bangalore. So you mentioned about themes for ATL. Like that, do you have any plans for introducing themes for like medical colleges, so that medical colleges can apply and be part of the Atal incubation centers? Because I guess some of the rules, they are not directly in favor of medical college. Like number of PhD staffs there, you'll not find in a medical college more than 2 or 3% of medical staff who have PhD actually.
Yeah, so first of all, incubators are open to any university, whether it is medical colleges or whether it is private industry and so on. We have not restricted it only to engineering institutions, management institutions. Anybody could apply. That is a constraint that we had applied on the number of researchers which are there and so on, because that tells us the quality of research that is going on, and therefore the potential impact on innovation. But this is something that we can look at, and it's a good input that you have given.
Lady at the back in the red, yeah, please, go ahead.
Is that me? Hi, I was wondering if the Atal Tinkering Lab is available only to rural schools or also to urban schools, both low-cost urban schools and the so-called privileged urban schools? Because oftentimes working in the field in rural areas, I find that some of the curriculum that we are rolling out there seems to be more advanced than what we have available in urban areas today.
I could also extend that some of the best innovations seem to come from the rural areas than just in the urban areas, but that's a general matter of observation. It may not be true at all points in time. 70% of our schools are government-aided schools, 30% are private schools. 650 districts out of 715 districts have been covered, so you can see that most of the rural areas have already been covered in terms of schools, ATL presence being there. We still have a long way to go in terms of the number of schools. We are hoping that by the end of this year, we'll have 10,000 schools having ATLs. But it is not restricted to urban or rural. It is pretty widespread. And there has been a conscious effort from our side to ensure that girls' school get special preference and co-ed schools get special preference as compared to just boys' schools. So it's not that the boys' schools are getting neglected, but we're making sure that the girls' schools are getting a little more attention because they deserve that attention in terms of, and surprisingly what we have found is 33% of our top innovators are girls in the Adult Tinkering Marathon winners. So it's not an insignificant number.
Why is it not 50%?
Why it's not 50%? Because we don't have 50% of the participants as girls. So 33% among the participants is a very good number, and it probably, if 50% of the participants were girls, then I guess this number would go higher.
Something to work towards. The lady at the back here. Yes, ma'am, yeah, please.
My question goes out to Mr. Ramanan. I am currently an incubator at an AIC center at Banasthali Vidyapith, also a STREAM educator for the past 5 years. Currently working on a line of STREAM products designed for the age group that is not covered by the Adult Tinkering Labs, which is grade 5 and below. And my question is that the decision makers and the educators, like the principals and the academic directors of a majority of the schools across India, have a rather myopic approach towards education and the relevance of STREAM methodology in schools. Even now, I mean, the question still comes up so many times that how will it affect their results in school? So is Atal looking at organizing or probably conducting a program that is directed only towards decision makers and educators, principals, trust members of schools across India?
Yeah, I think it's a very important point that you brought up, because even though we have Adult Tinkering Labs in so many schools, unless there is backing from the top management, and the top management realizes the importance of this, and they appoint teachers, dedicated teachers who aspire to influence the students and expose them to innovation, it will not succeed. So we do a number of programs across the country where we train the teachers, we also call the principals and so on. But I think we have to have a more structured approach with MHRD, which is the Ministry for all the schools and universities, and have a program. But we are already in touch with the directors of CBSE, Kendriya Vidyalayas, and all these schools to spread the message and have some special trainings conducted. We have a number of online materials which can be downloaded by any of the principals and see and go through. But we have to have a more structured approach with MHRD.
I just wonder if there's a sort of in the spirit of that question, is there a possibility to take this platform of labs and incubators and so on to crowdsource ideas for things like the robotics kit? Instead of being restricted to, these are my colleagues in Boston, so they were kind enough to come all the way.
Yeah.
But in principle, a lot of the people in this room could create games and kits and so on that would illustrate principles, from wherever they're coming from, right? I'm looking at those two gentlemen there from Itihasa, right? I mean, you guys are in the spirit of allowing people. Do you want to comment on this? Can you think of, is that a sensible suggestion? Why not use the infrastructure to crowdsource more and more of these kits and then use the platform to pump them out so that we have a whole pipeline of creative things? that are sort of coursing through the lifeblood of the educational system.
Right. Thanks, Tarun.
Can you introduce yourself?
My name is Krishnan, my colleague Daya Sindhu from Itihasa Research and Digital. Now, incidentally,
No, what I meant is introduce Itihasa as opposed to yourself.
Right. Itihasa is a company that studies technology domains, studies the evolution of technology domains in India. And we've been looking at technology domains like artificial intelligence, brain research, the state of this research in India. And we published a couple of reports. Now, one of the aspects was we are doing a colloquium on AI in IIT Madras later in April. And we were actually trying to look at some interesting ways to teach business folks artificial intelligence. So using game approach to teach them AI. So that's one of the thoughts. Thank you.
So just like that, I mean, I imagine that there are lots of people in the audience who could easily participate in this. Please.
Just to add, if there is more synergy between all of these kinds of efforts, like say Bangalore Science Hub, Tinkering Labs, Science Gallery and so on, there are many disparate activities. It would be nice to think of how there can be more synergy.
So we will be synergizing with the Bangalore Hub and Science Gallery, which I came to know only today through Kiran. And to answer your question, Tarun, I think ATL provides a great platform for stimulating innovation in new do-it-yourself kits, and also in the non-traditional engineering areas. Like for example, talking of life sciences, can we have DIY kits which is going to explain genetic structures and biotech and so on a little more easily to the students so that it excites their interest. So it's worth taking that idea up and seeing how to make it happen.
Do you want to finish your thought? Yeah, go ahead.
Sorry to.
Yeah, go ahead. No.
I was just wondering whether there's also space for citizen science kind of efforts, which could also, this could become like a hub, right? Then these centers, and maybe in the future, one could aim towards a time when students would want to go to a particular school because it has a Untitled Tinkering Lab, right?
That's already happening. One of the secretaries in one of the states, and I won't name which, told me that they're having a problem that many of the students are applying to the government schools because they're having tinkering labs, and the private schools, people have complained that they're not getting enough tinkering labs for the students to get attracted. So, yes.
Let me ask Dmitry and Ankur, do you want to comment on any of this?
Yeah, so actually the idea of crowdsourcing ideas for toolkits, so it has been actually somewhat tested during the initial years of Soft Robotics Toolkit project. As Dmitry explained, we had the Soft Robotics Toolkit competition, the annual competition, in which students from college as well as high school submitted their ideas, which were based on or somewhat related to soft robotics. And some of those ideas have actually in the past informed the designs of these toolkits that you're seeing right now, and other toolkits that are in the process of making. So it would actually be a good idea.
Sir, go ahead. Just a quick comment. I think for sure having a way to distribute these ideas and represent them in schools is important, and having ability for people to come up with ideas is big as well. But it's important to remember that every idea takes a lot of effort to get actually to the point where you can implement it. So, for example, this toolkit that you're looking at, we had this solution maybe a year ago or more than that. But when we actually started to do these workshops, we realized that there's so many fails happens, and so many ways where kids actually cannot use it, so many ways that teachers cannot use it. And we spent almost a year trying to tune it, modify to get to this stage. So I think it's great, and people should do it. It just takes a lot of effort, and people have to invest.
Just on the apropos this point about crowdsourcing and using the existing institutional structures as platforms, and then Uma's point of getting some synergy with whatever else is already going out and citizen science and so on. I mean, I think you remember the way I kicked off this event this morning was to say that the whole idea here is to create some platforms and bridges for people to start working together. So that's exactly the kind of thing that I'm hoping, that all of us are hoping would be triggered by this. Not that having a one-day event is going to change anything, but hopefully it's a start, and people can step up and find ways to plug themselves in. I just want to make one last comment about the mentors that I think Dmitry and Ankur and the Wyss lab in general have appreciated the role of sort of hands-on intervention to get people to the point where they can start using these kits and to get the kits themselves to the point where they are sort of autonomously usable, if that's the right word. I'm not sure it is, but and similarly in the ATLs, we've seen that without the mentors, who are ultimately citizen volunteers in the communities, professionals, scientists, etc., it's very difficult to get them up and running. So it really is a sense in which it's all of society really coming together to change to nudge the education system in the right direction. It's not just the province of people who are formally called teachers and so on, which many of us are. So that's one thought. I'm conscious that we're out of time, so I am going to ask you to join me in thanking the panelists. Particularly all the people who came long distances. And we're going to move very speedily and seamlessly into the last, I've recovered 4 of the minutes. Move to the vote of thanks.